Welcome to the Blind Apex Podcast, where amateur club racers tune in to get faster.
On this episode of the Blind Apex Podcast, we're talking about dampers. Some people call them shocks. Sometimes they're struts. You know, the things with knobs on them. I'm your host, Con John Turk. Joining me, instructor to most of the NASA Mid-Atlantic Honda Challenge field, a driver who evolved from Hondas, went to BMWs, and now has graduated to New Balance race shoes in his Corvette, captain of Bald and the Beautiful, Scott Blair. Welcome to the show.
Thank you, Con. I didn't know I was captain of the Bald and Beautiful. That's quite an honor. Thank you.
Well, I mean, I'm in the Bald and the Beautiful club, but you were my instructor, so you get to be the captain
That's right.
at least this time around. So,
okay, I'll take that.
Yeah,
it's an honor.
So, Scott, let's get a little bit of your motorsports background first, please.
Okay, sure. I mean, I've been at this for a long time. Not as long as Ross Bentley, but probably as long as anybody in NASA Mid-Atlantic or most club racers. I started out autocrossing, and for me, that was a huge leap forward and really made my learning curve a lot shorter for being on the track. I started getting on the track around, I'd say 06, after maybe 2-3 solid years of autocrossing, my E36 M3. I started running with NASA Mid-Atlantic, did a hyperdrive and then started regularly going. And I think after my first full year, I became an instructor. And that's really credited to the autocross. I just moved up real quick and then was able to instruct shortly thereafter. Dan Unkefer was my chief instructor. He basically trained us, and he was a wonderful kind of a mentor. So I think instructing came kind of natural. And again, I instructed you, so I don't know how from your side if the instruction went pretty well, but seems like I was able to connect and make people fast pretty quickly.
Oh, I think so.
So I love doing it. I started time trialing, I think, in 2009, and continued to instruct. And then around 2014 is when I converted my car into a race car, and kind of been racing ever since. So it's been about 9 years since then. And really, I've been racing, doing motorsports primarily with the E36 M3, which is a fantastic car. But a couple years ago, I just was kind of getting bored and wanted to change and wanted to go faster. So I went for the Corvette, which has been it's had more ups and downs. It's a blast on track, but I've been having some issues, keeping it running properly. So this year was kind of a throwaway, kind of missed nationals, but I'm hoping for next year to have a nice season, and then when it comes back to the East Coast, see what we can do with it. So,
oh, you almost fooled me.
I'm still hopeful.
I thought we were going to Miller Motorsports Park, man.
No, thanks. Now that's a big haul and a long time commitment. I love Utah though. I used to live there. I went snowboarding for 5 years. I moved out there just to go snowboarding. So I've always been kind of chasing fun my whole life, and so that's why I've been doing this motorsports for so long. I just can't shake it. So
yeah, you haven't found any extra fun activities to replace it yet. So.
Well, I've got this side by side. If you ever want to do a podcast on that, let me know. But I feel like it's a easy transition for motorsports guys to get into side by sides. It's basically a big off-road vehicle that kind of has the performance of a trophy truck. And to me, it's kind of like you can be Colin McRae. So it's kind of like racing, but through the mountains and trails. Mm-hmm. So it's also exciting. It's more like a time trial, because you're not side by side, but it's a lot of fun, and you can get a lot of adrenaline flowing doing that. So, yeah, I've always liked going fast. I'm kind of have that Ricky Bobby DNA. So, yeah, anything that's got a motor and go fast with, I'm usually probably going to enjoy it. So So two expensive hobbies, unfortunately. But hey, hey, you got to enjoy life while you can.
Yeah, you
right?
only live once, so you can't take it with you.
That's what they say. That's right.
So, all right. So we're talking dampers. What's your background with dampers?
So I was fortunate enough to work for a company called Stasis, which was headquartered originally in Sonoma, California, and then they moved to Summit Point, West Virginia. So that big building when you come into Summit Point says Garda World on it. That was built by Stasis, and they were an Audi tuner, and I was hired to be the suspension engineer. And I actually was hired with no suspension experience necessarily. I am a mechanical engineer, degreed mechanical engineer. And we do have to take a class called vibrations, which is spring mass damper equations to evaluate all kinds of topics, but it actually does come into play with suspension. So I kind of use my engineering background and also love of motorsports, combine those, and learned pretty quickly how to develop, design, build, test dampers. So my couple proud moments I had was we already had a kit for the Audis, the B8s, S4, A4, A6s, and all those, but it was poorly done. The damping was really bad. So I had we work with Öhlins, so I went and got some training at Öhlins in North Carolina, and came back and basically developed my own valving for the kit, and based on theory for the most part, using a bunch of vibration equations and optimal, using corner weights, motion ratio, or spring rates, wheel rates, ride frequencies, all kinds of stuff, and so based on that, it kind of gave me what the curve should look like. I changed the valving to basically try to match that force velocity curve for dampers. I know I'm getting ahead of myself here, talking about things we haven't talked about. But in the end, changed the valving, and the car was completely transformed. It went from a car that was just not fun to drive. It was really pushy, like Audis are. It was really sloppy. It took a while to recover from one turn to the next. And then with the new valving, it was just like, it was a car I wanted to own. It was so much fun. And it was literally just changing a few washers, which are shims, in the shock. So basically and again, we'll talk about that. But to me, what's the most amazing thing is just changing a few small precision washers in the shock completely transformed the whole personality of the car. So that was for me a big, the coolest moment, honestly, because I applied what I learned in it, and it just made the car fantastic. So, and I've always been a huge proponent of suspension and especially shocks, and I still believe the shock is probably one of the most important parts on the car. It definitely gives the personality of the car. The springs follow right as far as importance and giving the car its character. So, and then I actually did another thing I'm really proud of was building a set of race dampers. I think they were 3-way adjustables, and the race car that had the driver had previously, actually it was Tristan Herbert, and he was racing in SCCA Pro Racing, a Jetta, I think it was, and he had a set of custom valve shocks that he really loved, and I said, if you can get me the damper curve, I'll match it exactly. And he got it, which usually, companies don't share their curves, but he got that, and I was able to match it spot on. And I was really proud of that too, because that's kind of tough, to do that. So I was only there for a couple of years, so I'm not claiming I know everything, and this was 10 years ago, but definitely helped me to, understand the world of dampers a lot more. And, hopefully I can kind of impart some of this knowledge and help people with their own race cars and what choices they're trying to make to set them up.
Yeah, that's what we're here for, to learn. So you talked a little bit about the shock, the damper, and the spring. So can you give the layman an idea of what they do with the car?
Sure, yeah. Well, so if we look at shocks and springs, and shocks, dampers, struts, whatever. And just so everyone's clear, a strut is like a McPherson strut, but a shock is something where you have like unequal length A arms. So it's that's kind of the difference. So BMW, will have struts in the front. Most, older Hondas, have shocks basically, except for the newer ones. So anyway, that's the difference there between shock and strut, but they're all dampers. Springs, on the other hand, so springs basically will control steady state motion. Imagine going around on a skid pad at the limit without drifting. The shocks are no longer involved. It's just the springs that are controlling the amount of body roll of the car. So again, it's a steady state. Springs control steady state motion for the most part, and shocks are left out of it. So shocks are controlling transitional moments when the car is, transitioning side to side, braking, accelerating, or whatever. Basically, so in a traditional corner after a straight, like turn 1 at Summit or something, when you go from acceleration to braking to turning to throttle, each change in input is being controlled by the dampers. So hopefully that kind of gives a perspective of what the difference is. So then when it comes to dampers, you've got a damper does two functions. It controls the motion in compression, and it controls the motion in rebound. So compression, of course, is when the shock is being compressed. It's also called bump. Rebound is when the shock extends. Okay. So if we talk about compression, compression happens when the damper compresses to slow control the motion of the spring and the vehicle. A lot of times it's kind of hard to understand, the difference between what compression is effectively doing with the car. When you're changing your compression settings, you're changing your rebound, it's kind of hard to conceptualize what are you actually doing. So I like to think of it of compression controls the grip level of the car, the force the tires are pushing down on the pavement. And it's generally used to maximize grip based on the grip level or coefficient of friction of the racing surface and how smooth or bumpy the surface is. So the smoother the surface and the grippier it is, the more compression you can add. When it starts to rain, for example, usually you'll want to back out some of that compression, and will help the tires to maintain grip better. If we talk about rebound, okay, so now this is the extension of the damper, and what's different about rebound is the rebound is really controlling the body motion of the car, and it's generally used to balance the car. So, most cheaper dampers, well, if you think about like Coney's, right? Most dampers come, if they're only one way, they're usually rebound adjustable. And the reason is that's the way you can control the body motion. And you can use it more of a tuning tool, which we'll talk about. So adding rebound to the front or rear of the car generally would take away grip. And the reason it takes away grip is because it'll make the weight transfer faster, in essence, kind of, maybe shocking the car. So adding rebound makes the car feel like it's more like a go-kart, feels it more tied down, right? When you are, say, doing an S-curve or something like that, when you're making that left, right, left, if you don't have enough rebound, when you make that left and then go to the right, the car is still trying to settle from that first left, right? So it's, you're getting thrown around there because the rebound is not stiff enough to control that spring and to control the car. So when you crank down the rebound, it basically feels like it's just nailed down. It's tied down to the track. But the problem is you're kind of taking away grip. And in a similar way that sway bars kind of take away grip, more sway bar makes it stiffer, handle a little tighter, but again, at the expense of grip. So again, rebound, you want enough to where you're controlling the body motion of the car, but not so much that you're kind of sacrificing grip, basically. Okay. And then once you get that where it needs to be, you can tune the car by saying, hey, if it's understeery, if it's pushy, you can take rebound out of the front, or you can add rebound to the rear. And again, it just depends on if the car is feeling a little bit on the floaty side, then maybe add rebound to the side you want less grip. If the car is real tied down, take away rebound. If you can get away with taking away rebound, take it away from the area where you need more grip. So rebound again is more the tuning tool from a as far as the car being neutral and behaving the way you want it to, where compression is more of just overall grip that the car has. So I find it to be easier when I to think about it that way, and it helps you also when you're going to try to set the car up and initially, or when you want to make changes to the car. So I talk to people and they're complaining about how their car is driving. When I'm at the track, at a race, I'll usually suggest a couple things. Hey, just take out a little rebound here, add it here. And they'll usually come back and be like, man, it did what I wanted now. And so that's what you're looking for. You can make those small adjustments and get the car back to where you want it to be and to fit your driving style. And again, part of this is really fitting a driving style, not necessarily making it faster. It depends on how you like to drive the car, and you can tune the shocks with the rebounding compression to suit the way you drive. So
okay. Earlier, you talked about shims in a shock. What exactly is in a shock, and how does it work inside? I couldn't imagine that.
That's a good question.
I couldn't imagine two washers, even precision washers, right? Okay. Milled to a thou or whatever, however precise they are. I couldn't imagine that would really change how the car rides or the shocks work. So can you explain how they work?
Yeah, absolutely. I kind of nerd out on stuff like this. To me, that was just so neat just to, like you get a whole shim kit from Olin's, and it's basically like a little, 8x12 organizer box, and it comes with all the different shims. I forget, there's probably 30 different shims maybe, that it comes with. And I remember holding that box and being like, oh my God, like this, depending on what combination I pick, is going to completely transform the car. You know what I mean? And I could valve any car with this stack of shims. It's almost like if you think about a shock as like a computer, so it's how the hardware and software, they work together. A shock's hardware is, the piston, the shaft, the body, the seals, all these things. They're precision parts, they're high quality materials, usually larger pistons, larger shafts, the more volume in the shock, the better. And then high quality oil are used to all reduce friction and stiction in the shock movement, right? Because basically you're trying to get a certain, force out of that shock at a certain shaft speed, okay? And any friction is going to kind of alter that in a way you don't want it to. It's like adding noise to, a perfect reproduction of music. It's almost like having the more stiction you have, the more noise, and it doesn't come through clear. That's kind of what you're trying to do with a shock, is have almost no friction, so that way the damping curve you're trying to achieve, comes through in the performance. So we talked about the body being the hardware. So the software is then the valving, which comes from the shim stack. All dampers have a shim stack, pretty much, even non-adjustable ones. And really, the entire personality of the car comes from the shim stack. So again, like I said, that little box of shims is the personality of the car. For me, that was just mind blowing. So what is a shim stack? It's basically a specific combination of very precise washers of certain widths and thicknesses and preloads, kind of like a wave washer. You know how it's like preloaded, And these are used on both the compression and rebound side of the piston. The shim stack determines how hard it is for oil to flow from one side of the piston to the other, right? So that's all a shock. If you think of it in simple terms, a shock is basically a tube full of oil with a piston in it and a shaft. The shaft is connected to the upper side of your car, and then, the shaft is connected, let's say, to the chassis, to simplify it, and then the body is connected to the wheel, part of the suspension that moves, right? And so the piston is basically, when it moves up and down, it's moving through shock oil, and the oil is flowing through orifices in the piston from one side to the other. And depending on how hard it is to flow, determines how much force there is, right? So a shim stack is a way to kind of determine how much force it takes to blow through that piston, okay? And so that's what you're doing. That's the software. It's kind of like the ones and zeros. Depending on, when you're writing code, it's the same thing as using these shims. Do you want it to start out soft and then get stiff and so forth? And really, it's interesting because, it's speed dependent. Speed meaning shaft speed, so how fast that shaft is moving through the oil. Well, you can manipulate, the amount of force it takes. And if we just talk about, shaft speed a little bit, again, you're evaluating a damper based on how much force it gives at a shaft speed. Here's another really neat tidbit. If you ever looked at like a shock dyno or curve, and if you're listening, if you haven't, just Google it, shock dyno, or you'll basically see a graph, and the y-axis is the force and the x-axis is the speed. Shaft speed is what we're talking about. And so it usually goes from 0 to about 10 inches per second of shaft speed. From 0 to 2 inches per second. This is the whole region of, the handling characteristics of the car. And then from 2 to 10 is typically when you hit a bump, okay? So really, from 2 to 10, you're trying to, minimize, at least in my opinion, was minimize the forces when you're hitting a bump, right? You want to soak that bump up. If you're hitting a curb or something, that shaft speed is probably going to be closer to like 5 to 10 inches per second. But the 0 to 2, this is where, this shaft speed is when you're hitting the brakes and the car is diving, or when you're hitting the gas and the car is squatting, or when you're taking a right or a left, or a combination of all those. Okay, so the 0 to 2 speed is really when you're basically tuning for a damper. That's the critical zone that you're really worried about, And so, and again, if you look at a curve, you can't. You'd mentioned this before. If you look at a curve, how do you look at it and say, "Hey, that's a good curve"? It's really hard to. The best way to utilize it is comparing to, especially comparing to one that you like. But it's not just you look at the numbers and you're like, "This is good or not." So it can be a little tricky. So. But hopefully that helps as far as, thinking of the shock as both hardware and software. That shim stack is, like I said, that controls the force at the speed, and that's exactly that's how you're measuring the performance of a shock.
Okay. That's a lot to absorb for me. A lot of learning for me in that. I'll be re-listening to that for me.
Well, Okay.
I understand.
Yeah, I try.
I understand it, but I want to know it well enough to process it without being told. So it'll be. Okay. That was good information for me.
Well, did that give you any other questions that popped into mind, or it's just a matter of, hey, I need to just think on this a little bit more?
I'm probably gonna have to let it marinate because.
Okay.
I mean, that's just me. I'll be honest, I don't touch my shocks very often. I got my dampers from Redshift Motorsports. They said for this car, set it up this way. I did. it's still pushy. So I turned up the rebound in the back to try to get it to break traction back there. It worked a little bit. I will say that it was way sketchier going up the uphill S's at VIR with the stiff rebound. So I had to dial that back. But when I go to Summit Point, I dial it back up. But yeah, I don't really mess with my shocks too much. It's someplace, it's an area of motorsports that I need to learn a lot more. So, but, you talked earlier about over and under dampening. Can you explain that a little bit?
Yeah, sure. And for those out there who like to be pedantic, you want to use it's damped, or not dampening.
Okay, damped.
It doesn't really bother me, but I pointed out. Yeah, you're not making it wet. I don't know. That's just a little bit. It's basically dorky suspension humor, I guess, to point that out. Anyway, yes. So this kind of goes back to engineering a little. Well, completely engineering. So yeah, a shock. What it's trying to do is you have a system that's at rest, okay, let's say, and then you apply an input to it, or an impulse, like a bump. And what a shock is trying to do is bring it back to that rest point, or that equilibrium point, as quickly as possible. Okay. So think about if you want to talk about underdamped, think of a Cadillac with blown shocks. You hit a bump and that car continues to swing.
Okay.
I mean, basically think of I don't know, horses and carriages. They didn't have dampers; they just had springs, right? Like a leaf spring. And so you hit a bump and you just continue to rock for a few seconds until finally the oscillations slow down and you stop bumping. But in reality, you're probably just bumping all the time. Then someone, came up with the idea of a damper, basically to kind of, damp that vibration, damp that energy out. And so underdamped means, it's slowing down the oscillations, but not fast enough. If you think about like like in restaurants, they have those doors that have hinges on both sides. Or no, sorry, how about this? Like an old timey saloon, like in Tombstone or something, right? They got those saloon doors that swing open, right? They open and back. So underdamped means, you throw those doors open and they swing open and close, they go back and forth several times before they finally stop moving, right? That's underdamped. Overdamped would be if you swung that door open, it would like real slowly return to that closed position. And it wouldn't even overshoot. In other words, it wouldn't go past the closed position and then come back at least once, right? So overdamp means it doesn't exceed, the position at rest. It doesn't go through it and come back like an underdamped doors would. They'd swing open, and then they would open outwards, inwards, outwards. So yeah, overdamped is when it's swung open, it basically goes from being swung open to just shutting very slowly. What you're trying to achieve is critically damped, right? You're trying to basically dissipate this energy, return it back to its normal state as soon as possible. When I say normal state, what does that mean for a car? That means the car is now level again and squared up again. It's not flopping all over the place. Okay. So you're trying to take a turn where it's got to roll. Otherwise, if you had no suspension and it was like a go-kart, it would just skip all over the place. It would not have traction. You need to have, some suspension to maintain traction. But so again, this is the whole spectrum of what you're doing. Enough suspension to maintain traction, but that suspension has to recover quick enough to where the car is the stability is still there and it's not, not all over the place. So you're trying to achieve a critically damped system. And that means, if you think of the door concept, when the door is swung open, it quickly returns to the closed position. It overshoots slightly and then comes right back. So it basically will return, the system back to where it should be as fast as possible. So it's the best of both worlds, better than overdamp, better than underdamp. Okay. So Does that make sense?
Yeah.
That kind of explanation or analogy?
Yeah, it makes sense to me.
Okay.
The critical dampening or dampness, whatever. Now you got me thinking about my grammar.
Damping.
Damping.
Yeah, it's a weird word that people don't ever use. Yeah. So, but it's not dampening.
The grammar Nazis will be out. It's fine.
I was gonna say you're gonna have 5 people who are like, "Oh my god, yeah, you got to say damping." They're gonna be really hardcore about it.
So, yeah, so it makes sense to me. Where at critical, it returns quickly, it overshoots slightly, but then it returns back to 0, right? So
yeah, exactly.
It doesn't
as fast
as possible, and it doesn't overshoot wildly like when it's under damped, but it moves quickly, which is what you want, or which doesn't occur when you're over damped. So yeah.
Well, let me give one more quick anecdotal thing, and this is to nerd out. Now, again, I graduated more than 20 years ago, so I'm not fresh right out of the book, but it's really neat to me. I became an engineer because the laws of nature and are just so fascinating to me. It was such an amazing thing to be learning all the time. But there's 100% analogy between mechanical systems and electrical systems. So like spring mass damper systems is identical to resistors, capacitors, inductors. It's 100. The math is completely identical. It's exactly the same thing. Control systems are done exactly the same way as far as underdamped, overdamped, critically damped. So to me, that's really neat. Something mechanical and something electrical are 100% analogous. The way mechanical and electrical systems work. So I just thought that was kind of neat.
That's another thing I'm terrible at. The electrical system.
Oh, well, yeah, I'm talking about like theory,
right.
I guess, but no, for sure. If mechanical stuff is tricky, electrical is way worse because you can't see it. You know what I mean? So you can't see it to troubleshoot. So, but anyway, I just wanted to put that out there for the nerds because, hey, I think it's really neat, a special thing about just the way the world works. So anyway.
So say I know nothing about shocks, but I have a set of shocks, dampers, whatever, on my car, struts, actually on my Honda because I have a newer one, and I'm going to do a test day. What's a strategy for me to try to find that critical dampening?
Well, let me give kind of advice if someone were to maybe buy a new suspension and they want to, get it set up, right? Because that's obviously the first thing you got to do. So first thing is, start with a good baseline. If a lot of times, you buy a kit and they'll come with recommended settings. Like when I had my M3, first I built my own Olin setup, but then I sold that car and I had to start over with a new one. So I bought a set of MCSs off the shelf, 2 ways. And they had recommendations. So I kind of started there. But if you don't have a baseline, you can either kind of start everything at full soft and work up, or start in the middle. As far as I usually would start on full soft on compression. I think that might even be how I started setting up my car. So full soft, let's just say you don't have any guidelines or recommendations. So if you start full soft, compression and rebound, start by tuning the compression. At least that's my suggestion. You might have other people say other things, but I like starting with the compression. You tune that just stiffer and stiffer until the car starts skipping over bumps. And here you'll kind of want to ignore the body motions, the body roll for the most part, as you're going to change this and tune this with the rebounds tuning. So focus on compression. Usually bumps in the braking zones are a good test. And if you can get any bumps, when you're turning too, that's good too. Like it makes me think of I don't know, kind of Summit Turn 9 is one where you get bumps and turning, kind of near the apex. Anyway, you want to increase compression until it starts skipping over these bumps, and then once you hit that point, back it off to the previous setting, and then kind of leave it there. Then start tuning the rebound. And you're going to tune the rebound until the car starts feeling, more in control. Initially, it'd probably feel like kind of a boat, and maybe take too long to recover from transitions, like a bus stop at Watkins Glen or the uphill S's at VIR, right? If we think about the uphill S's, I guess we're probably more familiar with. If you're turning, let's see, into that first S, and then you're going to that second S, and the car is still trying to settle from that first one, you probably are going to need more rebound. You want that car to be settled before you make that next turn. So that's what you're trying to achieve there. You're trying to, increase rebound until it's really drivable. You can keep turning it more, but you run the risk of kind of going beyond the optimal settings. You can, if we talk about critical damping, you could potentially go into the over-damped stage, and you want to be more critical damping. You want to, settle quickly, so you can pretty much move to the next transition. So yeah, that's really kind of the advice I would give. Let's see. Once the car overall starts to respond, how you like it, it starts to feel good for the first time, then I'd suggest use the rebound to set the balance of the car. Okay, so you mentioned your car is pushy understeery. I always seem to have that problem too. Now, one note is sometimes my driving was a little bit too aggressive. You think about the DE3 guys; they're usually they're confident. They don't really have a lot of fear, but they all tend to share the same problem, is that they're just too aggressive on stuff. They slam on the brakes, they slam on the gas. They're not being smooth. That's the next thing they got to work on. So sometimes driving style can make a car. I know for me that had happened a little bit in the early days. I would just be too hard on the brakes and then pop off the brakes.
Right.
And then the car wouldn't turn. I'm like, oh, this car's understeery, but really it was my driving issues. But anyway, assuming that's not in the equation, if the car is pushy or understeery, then you can do two things. You can soften the front rebound or stiffen the rear. So that right there is probably some of the most golden advice people would want to take away from this podcast, of course, is what do I do with my suspension to make it handle the way I want. So pushy understeery, soften the front if the car is already pretty. Just as a general rule, if the car feels pretty stable and good, you soften the front. If the car feels like it's a little bit soft anyway, maybe stiffen the rear. Then conversely, if the car is too loose, stiffen the front or soften the rear. So, and then also it depends on, where is it loose or tight? If it's entering the turn or exiting the turn, that could influence, more do I soften the front versus the rear. But in general, that's kind of that's certainly my suggestion on how to get it tuned to where you want it to feel good. But also be careful, going too far to extremes. I remember a friend had a S2000 and he was just like, man, the car just doesn't feel good and all that. And I drove it and I was like, oh my God, it was way too bound up and tight. Mm-hmm. And I was like, what are your shock settings? He's like, everything's on full stiff. I'm like, let's like soften that back up, man. Let's bring it back into the middle of the range. And after that, it was great. You could, the car had some compliance to it. You could feel it moving. It didn't just step out on an instant. It had a little bit more. It just felt better overall. And he was like, oh my God, this car is much more drivable, much better. So you don't, just because it's stiffer. It's like people, you get into a rental car and, you always, the the settings are always max bass and max treble.
Yeah,
You know what
yeah.
I mean? And it's like, that doesn't make it sound better, just it needs to be in the sweet spot, not just cranking it up. So that's the same with suspension. So,
Yeah.
so yeah, hopefully that's going to be, shed some light on things for people a little bit.
All right. Yeah. Yeah, that helps. So say they bought their brand new MCSs, Penske's, Bilsteins, Olin's, something, right? When do they need to start looking to do maintenance on them?
Well, that's a good question. That and it always depends on what kind of what shocks you bought, really. Something like a Bilstein, that's a great mass-produced shock, and it can go like 100,000 miles without needing any service, any maintenance, any of that stuff. But race shocks, they're going to have a lot more precise parts. Everything is, every part is chosen to basically be precise and to reduce friction. And so that means rebuilds are going to be more frequent, right? So something like an Olin's or a Penske, and again, depending on how, racy it is, I'd say it could be every, as much as frequently as every few races, maybe for like pro racing, or even hundreds of miles. Most racing dampers, though, club level, I would say every 2 to 4 seasons is a good idea to rebuild them. Not every season, I don't think. I think that's probably too frequently, but every couple or 4. It just depends on what your budget is. I usually, even though I'm a suspension or was a suspension engineer, I would push mine as long as I could. Usually like 4 seasons, I would try to get out of them. So if you notice that it's leaking, you'll need to obviously remove it and rebuild it right away. I mean, a leaking shock is a dead shock. That's not going to be working. And you'll feel that right away when the performance feels off. But if you let it go 4 seasons, the performance is going to degrade some. The oil breaks down. It's kind of like oil in your car. It's not going to do as good a job. And the seals, are going to start to wear. So it's going to change the characteristics a little bit. So instead of being 100%, you might be down to that 85% range. So certainly if you have the budget, rebuilding it more frequently is better. But like I said, every 2 seasons probably a good on the more frequent end, and I wouldn't push it past 4.
Okay.
So for like club racing level stuff, yeah.
So the next question I have is, how do I know when I need to go to a shock guru rebuilder and say, I need these revalved?
So revalving is really needed if your setup is not really working together. If the weight of the car, the spring rate, and the dampers are not in the same ballpark. I don't want to say matched. I mean, they should be matched, but there's a range. Dampers have a range if they're adjustable to handle different car weights, different spring rates. So you can always kind of tune within reason. But if the car feels like it doesn't, settle quickly on transitions, or it feels too stiff once the springs are controlled, it might need a revalve. If it's way too underdamped or way too overdamped, basically. Since revalving is pretty much only done by suspension tuner, you would just tell them what the car is doing that you don't like. And I mean, and what I usually say, people ask, like what does a good suspension feel like? Honestly, I think a good suspension feels like nothing. You kind of forget suspension even exists, and the car just does what you want. I'd say you notice a bad suspension pretty quick. You notice, you know what I mean? Like, it's not that you notice what's so good about it, is you notice when something's bad.
Right.
So, and you'll notice that usually pretty quick, especially if, you're in, well, like I get into lots of different cars, throughout a year. I'll do coaching or instructing or racing or whatever. So I get in different cars, and right away I can be like, oh man, this thing it's not good. Especially when I was in GTS2 and I would ride another, racers' cars, and immediately I could be like, oh yeah, this is really nice, or oh yeah, this is this suspension's not either set up well, or maybe that's usually the case. I don't think I got in a car where it's like the damping and the springs don't go together. But anyway, my point was a good suspension feels like it's not there. It doesn't get in the way, and the car does what you want. A bad suspension, will not allow the car to react or behave the way you want it to. So, yeah, and to answer the question, you talk to someone who basically offers that service and say, hey, here's what the car is doing. And then they might ask more questions. So really you want to kind of have a good feeling about what's it doing, under braking, under trail braking, under, at the apex and then that corner exit. If you can distinguish, okay, well, it's doing it at this point or then, that can kind of help a tuner to decide what changes to make. Okay. I'd say so. But yeah, if your car is typically on the heavier side, right? So you might be needing more towards a revalving towards being a little bit stiffer, a little bit more damping force overall, I would say.
Okay. So you mentioned that each damper would have a spring rate zone that you can be in. Mm-hmm. Can you go too soft? So say traditionally my car sprung pretty stiff. If I swap that spring to something, say, half as stiff, do you think that would cause an issue?
Well, one way to think of it is with a certain damping force and a certain spring rate is going to give you a known damping force and a known spring rate. That's going to either be underdamped, overdamped, or critically damped. So there is theoretically a sweet spot of being critically damped that a certain spring rate and a certain shock valving, a force at a certain speed will give you. So it is possible, okay. Yeah. So for example, if your suspension is perfectly set up, your dampers are matched to an 800-pound spring rate, and then you go to a 400-pound spring rate, that might be, let's just say they're non-adjustable, because the adjustment range might give you such a broad range, a big enough range to cover 400 pounds of spring rate. Okay. And again, speaking kind of generally, yeah. But yeah, there is a point where the shocks are overdamped. The only example of that I can kind of give is when I built my Olin setup for my M3, the fronts I was able to follow recommended valving from Olin's that they did on some of their pro race cars when the E36 first came out. But the rear, I kind of just built that custom on my own, and I picked what I thought was a good compression curve, valving for what I thought, and it was way too stiff. The car was just like undrivable. I could feel every pebble in the road. I was driving it to Summit, and I was like, this is just so stiff. It was just like it was skipping off it was bouncing off everything. It felt like I never felt anything like that. It was just way too stiff. So immediately I knew the valving was way over damped and needed to change. So I basically kind of cut the compression in half. It was like 200 pounds at 10 inches. That probably won't mean anything, but it needed to be about 100. And I tried to do research. And again, it's very hard to research. When you're a suspension engineer, there's at least 10 years ago, there was no information out there. Nobody shared anything. Right. So it was very hard to, you really had to like scrape every corner of the internet to find stuff. And I finally found other shock dynos, and I was like, yep, they were around the 100 mark. So anyway, yes, in that case, you can be, have too much shock in the car.
Yeah, you can. Yeah, even if it's all the way soft, it could be a range between 400 and 800. So you could never go down to a 200-pound spring.
Yeah, that's that's right. That's okay. Right. So,
yeah.
So it is possible, but usually, yeah, you buy a kit, they're usually made to suit that particular car.
I think I'm out of questions. Scott, is there anything on your list that you wanted to cover that we haven't touched on yet?
Well, I don't know if we touched on this, but when you think about suspension, that's probably the most important part of the car's, influencing the car's handling capability. But when you're trying to make a car handle, there's, I would say, kind of 5 main things that will influence it. The first one, and maybe arguably in some ways almost as equal, but in a totally different way, is like the alignment, right? So, camber, caster, and toe. Camber, and again, when you think about these things, as far as like what's your approach to set a car up, if you're racing, the best way is to follow what other people are doing, and then work from there, because that's going to give you a good baseline. Let's use the E36 M3 for example. And actually, I wrote an alignment guide years ago, and it's still kind of considered the gold standard for BMWs, really. It's on Bimmer forums, which I know forums aren't really a thing anymore, but
they're coming back.
Yeah, it kind of tells you how to set up camber, caster, and toe on our cars. Strut car, unlike a EG DC, or EG Honda Civic DC Integra, which has got a really good suspension setup, or Corvette or Miata, the unequal A-arm, wishbone setup. Those suspensions and their range of motion as they go through compression, they gain camber, right? So, which is ideal. As the car rolls, it compresses on the outside, and so the tire cambers in, so that basically the contact patch stays flat on the ground. And that's the whole thing. What you're trying to achieve here is keeping that tire tread kind of square to the road at all times. Right. That gives you the maximum traction. So, and the alignment plays a massive role in that. So camber, if you E36s usually need 4 degrees almost, because you don't gain any camber on bump because it's a McPherson strut car. Same with your car. And that can also make a car pushy if you don't have enough camber. Caster is a little bit harder to not only to talk about or evaluate, but to really feel the results. Caster, of course, is like a shopping cart, has 0 caster, like a chopper from the movie Easy Rider, where the forks go way out long. That's got a ton of caster. Caster is nice because it self-centers the wheel. So like if you're in a turn and you let go of the wheel's going to want to snap back to center. That's what caster kind of does for you. But it also can weight jack wheels. So anyway, caster, go with what's recommended. Toe is another huge one too. Toe in typically makes the car more understeery, more stable, and factory settings for cars call for lots of toe in, and it's just awful. 0 toe makes the car real lively. It makes it want to turn, but a little bit unstable. So depending on like an E36, again, I would usually run 0 toe or a little toe out in the front, so that way when you turn in, it just really wants to turn in nicely. And even 0 toe in the rear, because again, I like the car. The way I set the suspension up would also influence that. So nothing is on its own. They all interplay. So if your car is loose with suspension, maybe some toe in could bring it back to being a little bit more tight, and vice versa. So
okay.
But anyway, alignment is key. The other main thing we talked about, dampers, springs. That's the biggest thing. Sway bars too. Personally, I like sway bars as just a tuning tool. I don't like to add a lot of spring rate with it. Over the years, tuning my M3, I just started going with less and less sway bar. And I remember when I was going around Oak Tree and I kept lifting that rear inside tire, and it would just spin and not put power down. Okay, maybe it was a failing diff too, but when I finally got rid of that rear sway bar and add a little bit of rear spring rate to keep the total spring rate in the rear the same, the car just hooked up and I was able to get on the power early, getting out of there. So sway bars I like just to kind of do a little bit of tuning balance, but the Honda is different. So
yeah, we're
I
real
know
different.
You guys are way different. So yeah, I don't have enough experience on front wheel drive cars to give pack leading advice here. So your mileage may vary. And then finally, corner weighting and corner balance is another thing that's helpful. If you can basically get the weight of each wheel or tire, put a scale under each tire, if they can be all four equal, that's ideal, and then closer to the center, the better, because you've got moment of inertias and stuff like that. But corner balance is another thing. But again, alignment, spring shocks are the most important, then sway bars, then corner weights, and then finally add lightness. That's going to help too. The less mass to, the easier it is to turn, to brake, to accelerate. So those are kind of the 5 things that allow you to get the most out of your car's handling capability too. So once you get all those working together, and the car can be magic. So
it's a lot of work though.
It's kind of the big picture. Yeah, it is. I mean, fortunately, I went to a new chassis, and it hasn't been too bad. Part of it's I don't have a lot of things to adjust, but the M3 was definitely, it was a long evolution. And it kind of from where I started autocross, and it worked for autocross, and I had to make some changes for the track, and then, it really changed quite a bit. But and the other thing is another interesting thing, maybe the last thing I'd say, is there might not be one right setup for anybody. With my M3 race car, I always ran a soft setup because my theory was, the softer, more compliant. It doesn't overheat the tires. The stiffer it is, it can heat those tires up real quick. So if your time trial maybe stiffer is good, it'll get heat in that tire real quick, but then it can burn them up quicker. A soft, more compliant car will, won't shock the tire as much. It'll ease it. But it's different driving a soft car. It kind of feels a little bit more like a boat. When you turn in, there's more of a lag. You have to let it take a set, bite, turn in, and go. So your turn in points will change. So I ran a soft car, and everyone else was running stiffer cars. And finally, I'm like, well, I want to see if the car's any faster if I run like everyone else stiffer. Added pretty much 200 pounds, 250 pounds around the whole car. And it was easier to drive in a sense. It was more responsive. It didn't lose much on the curbing as far as getting unsettled, but the lap times were pretty much the same. So, I would say get the car drivable to the way it suits your driving style. A hard course, the guys at Olin's it's funny, I remember they would say, I don't even care what the driver wants. I'm going to put on a shaker rig. It needs this damping. It needs this spring rate. That's what you get. You know what I mean? Right. So, but, and maybe, at the F1 level and at those extreme levels, sure. But, you want a car that you can live with. At this point in club racing, a lot of it has to do with how happy the driver is and comfortable they are. And, make sure the car feels the way they want is just as important sometimes as maximizing the theoretical grip out of it. So,
yeah.
Something to keep in mind. Yeah.
All right. Well, I think that's going to be a podcast. Do you have any partners or anyone you want to thank for the help throughout the years on your E36 or on the new Corvette?
Well, you say partners, so yeah, I definitely want to thank my wife and for being so awesome and allowing me to continue my hobby and doing what I love. And she's been very supportive. And I'm the time trial director, for NASA Mid-Atlantic. She's also the time trial director. She does it pro bono, but if she didn't do it to help me, then I would be in big trouble because she does a lot of the behind the scenes stuff.
Yeah. Awesome.
I'm kind of the face of it, which doesn't say much, but she does a lot of work. But no, as far as shops and stuff and support, GT Piece is kind of the shop that has been there for me and supported me. And they're the only person I would trust looking at my car. And they have a lot of racers kind of, taking their cars there now. I think they're probably the best shop out there.
Me included.
So that's okay. There you go. So that's absolutely my recommendation because it's hard to find a shop you can trust and is competent, and they're both.
Absolutely. So. Absolutely. Yeah. And where can they find you if they want to find you? I know you'll be at NASA Mid-Atlantic events, but, do you have any social media you want to promote or any of that stuff?
No, you can find me on Facebook, I guess. I'm old, so I'm on Facebook.
You're not that old. I'm probably older than you are, Scott, so it's fine.
Well, we're both young at heart, I think, except for social media.
Yeah, well,
I don't know.
all right.
You can don't call me, text, but
See,
no,
you're
not
in that sweet spot.
I have Instagram, but I don't really use it. Yeah. I don't know. Reach out to you and then reach out to me and then we'll figure out a way, I guess.
That's fine.
But no, I'm not really a big social media guy.
Yeah, it takes too much work. I don't know why I do it sometimes, but anyway. I really appreciate.
But I hope it was.
Yeah.
Yeah, I hope it was interesting.
I'm sure it is. I'm gonna have to listen to this a couple times just to glean more information. It's a lot to absorb, so I really appreciate the time that you took to come on and all the information you were able to share, man. I appreciate it.
Absolutely, Con. It's my pleasure, and it's fun to talk about it. So I know I was trying to distill a lot of topics into just an hour, but hopefully it made some sense and it was beneficial. So,
oh yeah, it's beneficial. Thanks for coming on, man.
Absolutely. We'll do it again sometime. Thanks a lot for having me.
Until next time, keep working on yourself, keep working on the car, and let's get faster.